University. Today we are looking at network design. Okay, our course is network design. We're looking at chapter 1, and chapter 1 is known as LAN design. We're going to look at the LAN design. LAN means local area network. So we're going to look at how local area network can be designed for enterprise network, okay, to suit enterprise network, following what we call the CCNA routing and switching Cisco system. Now let's take a look at the first part. Here we're going to look at chapter 1. These are some of the sections we're looking at and the objectives. Now we have two main sections, or the third section is a summary. The first section we're looking at is the campus wired LAN designs. That's the first section we'll be looking at. The second section we'll be looking at is the campus network device selections. So devices we need to select in order to design a campus network, right? Now here are some of the objectives. In the first section, which is the campus wired LAN design, we'll be looking at how we will explain why it is important to design a scalable hierarchical network, why we should have a scalable hierarchy of network that can be expandable, And then the second objective is to look at, or sub-objectives of that section are to describe the hierarchy of small business network design. We're going to look at small business and the hierarchy of how we use our interconnectivity of the network devices. Then another objective to look at here is to explain the consideration for designing a scalable network. Now, the second part, which looks at the campus network device selection, here we'll be looking at the first objective here, under this category, is to select the network device based on the feature, capability, and network requirement. The sub-objectives that are found here, or that we need to grab in this subsection, is to look at select the appropriate switch hardware that we need to use for our network, right? That is suitable for our network, whether it's a small network, it's a medium network, a switch that is suitable for that type of network. Another thing we'll be looking at is to be able to describe the types of routers that are probably available, either Cisco routers, which are very popular, the Cisco routers that should be used for small or medium size business network. Now, without much ado, let's begin. Now, let's start with the first part, which is the campus wired local area network design. Here, we'll be looking at the Cisco validated design. Okay, here, take a look at this. We have what we call the need for us to scale the network. Now, for example, if you have an enterprise network, you can have your branches. If you have a business, a company, you can have an enterprise network that spans from different cities. Okay, enterprise network that spans in different cities. For example, you can have office in Osaka, in Japan, okay, of your enterprise network. You can have your network in Japan, set up in your office in Japan, in Osaka. You can have your office in New York, set up in New York, okay, for your enterprise network. You can have your office in Boston, in Massachusetts, okay, set up an enterprise network within that geographical location. You can have your office in Orlando, in Florida, okay. So all of this needs to be interconnected, and to do that, you need the Ethernet. You need the Ethernet to interconnect the various network in the various of your enterprise in the various geographical location using the Ethernet. Okay, so by doing so, we're going to need some network devices like the router, which will enable a gateway to route whatever data or your packet or traffic from one enterprise office to the next branch of your office, okay, so that you can interconnect between your enterprise, branch offices in the various geographical locations. Now, a company with a small network size on site and connections to the Ethernet might grow big, right? Every small company's intention is to grow big. So when the company grows big, therefore, the network is going to span in different geographical areas. So by doing so, you're going to create an enterprise office network for various offices. And when we do that, all the enterprise network must be able to support for all your offices, whether it's in Boston, is in Orlando, in Florida, Boston, Massachusetts, or your office is even in Japan, is in Osaka in Japan, or your office is in New York, maybe your head office. You can see our network enterprise, we made New York as our head office, right? You can see New York is the headquarters of your offices. Now, let's assume that everything you broadcast will have to go via the internet, right? To all your other offices, to the Osaka office in Japan, to the Boston office in Massachusetts, and your Orlando office in Florida, and even office in Kuala Lumpur, for example. Okay, so if you have office in Kuala Lumpur, so you should be able to design a network that can support all of this. Enterprise network that must support the exchange of various type of network traffic. So there must be your network, the design of the network must be able to support the exchange of various type of network traffic. So whether it's coming from Osaka office, Kuala Lumpur office, Orlando office, Boston office, New York office, Lagos office, whatever office, Johannesburg office, wherever your office are located. So must be this network, your enterprise network must be able to support that. Another thing is that your enterprise network must be able to support critical applications. Okay, critical application for your business. And then another feature that must be in place for your enterprise network is that it must be able to support a converged network traffic. So when there is a converged traffic is coming from different offices to one location. For example, there is a network traffic coming from New York to Boston. There's network traffic coming from Osaka to Boston. There's network traffic coming from Kuala Lumpur to Boston. There's network traffic coming from Orlando to Boston. There's network traffic coming from Lagos to Boston. So all of this network must be able to converge into the Boston office. Must be able to converge into the Boston office. If not, then your enterprise network is not robust enough and is not designed properly for suitability and scalability in the business world, right? Now we move on to the next one. We say a good enterprise network must also not only converge traffic, must also support diverse business needs. So must also be able to support diverse business needs. So if the business is bringing a new product or is introducing a new product line, then the network should be able to deal with it. Okay. Then another thing is that a good enterprise network must be able to provide centralized administrative control, maybe usually in your headquarters. Okay, a centralized administrative control. A very well-designed enterprise network must be able to characteristically provide a centralized administrative control. Is that okay? Now let's move to the next point, which is still on the need to scale the network. Now, the local area network is the networking infrastructure that provides access to network resources for end users over a single floor or within a building. So here we are characteristically explaining what is a LAN. Okay, we are characteristically demonstrating or showing what a LAN is. So in a simple term, a LAN is a LAN can be seen as something that is a networking infrastructure that provides. So a LAN is a networking infrastructure that provides or enable you to have access to a network resource. Okay, networking infrastructure that enables you to have access to network resource for any end user in that enterprise, for any end user in that enterprise over a single floor building. So if it's not beyond a building, let's say beyond a building, it's a scaled one, like a campus. You know, the campus network is beyond a building. You have multiple buildings in a campus, different faculties, different departments, okay, which do not necessarily have to be on the same building. So if your faculty of engineering is typically and characteristically different from a building in the faculty of social sciences. So this one is a very big local area network. But for a small enterprise or medium-sized enterprise, a LAN is usually a networking infrastructure that enable you to have access to a network resources within a building. Is that okay? Now let's move on quickly for the sake of time. Now let's take a look at the hierarchical design model What are the modes there? Now, first you have the Ethernet. The top layer, we have the Internet here, right? We have the Ethernet layer. Beyond that, we have the firewalls. You know, your gateway to the Ethernet, you must have firewalls, or you must have access control and other security architecture that goes with the network. Now, after that, we begin to segment the network layers, right? We segment the network layers into various categories, or break it down into various layers. Now, the first layer is called the core layer. The core layer have direct interface with your security apparatus, your security like your firewalls, have direct interface with the firewalls. Okay. Now, after the core layer, we have the distribution layer. In the distribution layer, here you have your routers that does the distribution work to the various switches. Okay, that distribute or forward packets to various switches, and these switches we forward layer 3 switches. We therefore forward these packets to the designated port or designated device that's supposed to receive this traffic. Is that okay? So after the distribution layer, so the first one is the core layer, which we've described, and then the second one is the distribution layer, which comprises of routers that does the forwarding to the switches. The last but not the least is the access layer. The access layer is where you have the switches, where you have the layer 3 switches. Okay, routers are layer 2 devices. Okay, the access point, the access layer is where we have the switches, where everything is now forwarded to IP phones, where everything is forwarded to our computers, the modem, and all of this stuff. Is that okay? Now let's quickly take a look at breaking the design into layers. We've talked about that. We say the design, in order to have a very robust design, we must break the design into layers: the core layer, the distribution layer, and the access layer. So if you're designing a network as a network administrator or a network engineer, you must first of all characteristically calculate and estimate and this breakup of the layers of this network: the core layer, the distribution layer, and the access layer. Is that okay? So this will simplify the deployment of your design and network devices. It will make it easier the deployment and the management of these network devices, to make it easier and simpler for you. Okay, and it will make it easier for us to implement the network that we have designed and developed. Now we move on to the next thing. The hierarchical LAN design includes 3 layers, which we've mentioned already. Is that okay? Now let's move on quickly to the next phase. Here we're looking at expanding the network. To expand the network, you need to look at the design for scalability. So you need to design in a way that the network can be scalable, can be improved upon, can be upgraded, can be added upon, okay, can be modified. Okay, if you don't design a network in such a way, that it can be upgraded, that it can be added upon, that it can be modified when needed, then the network is not going to be scalable. It's a poor design. Now let's take a look at that. The network designer must develop a strategy to enable the network to be available and scalable easily and effectively and efficiently. Is that okay? And efficiently. You must have all this in place. When you're designing a network, you must create what we call the redundant area. So that such a way that when a link in your network breaks, the redundant one will be used. Okay, will be calculated quickly and will be used by the system. Now, in order to make our network expandable, we need what we call the modular equipment or the cluster devices that can easily be upgraded to increase capability of the network. So we need some of these things to be, so when we design a network, we need to think of modular equipment such as modular switches, modular routers, and so on and so forth. And we need to look for also the clustered devices also should be added in order to increase, to be able to upgrade the network when need arises, in order to increase capability of performance throughput, what we call the throughput of the system. Is that okay? Now, design a hierarchical network must include modules that can be added, upgraded, like we said earlier, added, upgraded, and modified when needed. Then another thing that we need to, for scalability, that we need to put into cognizance is ability to create an IP version 4 address or IP version 6 address strategy that is hierarchical. That is very hierarchical. Okay, we need to put this into complete consideration. Then another thing we need to check quickly is to choose routers or multi-layer switches. You know, not only router that can do this, there are what we call multi-layer switches that can do this job. We need to choose routers or multi-layer switches to limit the broadcast or filter the undesirable traffic that is on the network, that's coming from the network or from any other network. And then another thing we need to do, which is very important, okay, in order to have great efficiency, another thing we need to do, which is very important to improve the efficiency of the network, is to implement a redundant link. I've mentioned it earlier. We must create this area 0, what we call the area 0. We must create what we call the redundant link. We create it ahead of time. Why? The reason for creating a redundant link ahead of time is to ensure if there is a break in the network transmission, then the redundant link can be switched to and be used immediately in order not to put the network into shambles or darkness. Is that okay? So we need to implement the redundant link between the critical devices and between the access and core layers, between the access and the core layers. Is that okay? So it's very important. Now let's move on quickly for the sake of time. Planning for redundancy. Then, since we've mentioned the redundancy, how do we plan for it? The area 0, how do we plan for it? Now, redundancy, first of all, is an important part of network design. So when you're designing as an engineer or a network administrator, you must remember to design a redundant path. Now, when you're designing a network as a network designer, you have to take into cognizance that the redundancy is an important part of the network design for preventing disruption of network services. If you don't want to have network epilepsies, network failures, you have to create what we call the redundant path. Okay, you have to create it. When we create this, what does it do for the network? When we create a redundant path, how do we now decide to create a path in a network that is idle? It's not doing anything. Someone might say, oh, wouldn't this be like waste of resources, waste of money, waste of whatever resources we have? Yeah, it could. It's because there must be a trade-off. It could be seen in that direction. However, the advantage outweighs the cost, because when the network is going to fail at the critical moment, that will cost you millions of dollars, then the redundant path will save you from such a disruption that will cost you millions of dollars. So that's why it's very important for us to have a backbone. This redundant part, the LAN redundancy, is called the backbone. Okay, it's called the backbone. It's your backbone. Okay, to save you from losing millions of dollars as a result of network failure. Now, so we'll be able to see the significance, the importance of having a backbone or having a redundant path, right, in a network. Now let's begin to look at the advantages. It helps to minimize the possibility of single port of failure by recognizing the following. Now let's take a look at them one after the other. Here, installing duplicate equipment, because you go to install duplicate equipment, which may ordinarily which looks as if you're wasting money, right? Because you're installing duplicate equipment, and those duplicate equipment, you already installed them in the network and you're not needing them right now. So since you're bringing them in and you're not needing them right now, temporarily, it looks as if you're going to waste money, but that's not the case. That's not the case, because network will certainly fail. There are so many factors that will make failure inevitable. Now, one of the things that saves you is to have a backbone, and this is what we mean by this. Installing the duplicate equipment and providing failover services for critical devices is very necessary. So failover, this will improve your reliability of the system network and save you from failure, system failure, network failure. Is that okay? Now let's move on. Another advantages of this is the redundant path offer alternative physical path for data to traverse the network. So it creates alternative path for data to traverse in case of congestion, traffic, data traffic, of congestion in your network. So this redundant part could be used. So it's not only when the system fails, when there is, because you've grown, your business has grown, your company has grown, your business is doing great, you have branches everywhere in different cities, different countries. So you need to create a redundant path. And when there is traffic congestion, and we are talking about data traffic now. When there is I'm not talking about physical car traffic. That's not what we say. We're talking about data traffic. When there is data traffic and there's data traffic congestion, then the redundant path could be an alternative path quickly for data to converge through to the branch office that you send your data to as fast as possible. Is that okay? So this is an advantage. Now we've seen this now. Now another thing you can do to enhance this redundancy is creating the spanning tree protocol. And the spanning tree protocol is required with redundant path in a switch Ethernet network to prevent layer 2 loop. Because when you create this, when you create a redundant path, you also need to create what we call the spanning tree protocol. The reason for creating a spanning tree protocol when we have a redundant path is that looping will occur. There will be a looping in the system which is not good for you. So we need to create a spanning tree protocol to prevent looping on the network, okay? So now, since we measure spanning tree protocol, STP, let's have a brief look at it. STP provides a mechanism for disabling redundant path, okay? It has the ability to disable the redundant path in a switch network or the path is needed, is necessary, is needed. So when there's no need for it, it will kind of disable it. That's why a spanning tree protocol is very necessary to be created when you have a redundant path. And a network needs a redundant path. So because a network needs a redundant path and we need to create a redundant path, hence we have to create a spanning tree protocol. Why? Because the spanning tree will prevent the redundant path from looping. If it's looping, it's costing you money. It's costing you a lot. Okay, it's costing you a lot, wastage, and so on and so forth. So we need a spanning tree protocol. Now let's move on for the sake of time. Now failure domains. Let's take a look at expanding the network. Let's take a look at failure domains. Some of the failures that can happen, from the internet, the big world wide web, the internet, then your data comes to your router. Or first is through your firewalls, then to your router, and then your router forward to your switches forward to your workstations in your organizations, and also to access points, and so on and so forth. Is that okay? Now, let's take a look at some of the failures that can happen. A well-designed network should limit the size of failure domains, because if your network repeatedly fails, it means the design was very poor. It means the design was poor. Now, a failure domain is the area of a network that is impacted when a critical device or network service experiences problem. So the failure domain is where the impact is highly felt. Okay, so that area is called the failure domain, where the impact, when a problem occurs, where the impact is highly felt, is called the failure domain, right? Okay, now the functions of the device that fail will determine the impact of the failure domain. So it depends which device failed. If a router fails, the impact is huge, because the router is the gateway to the World Wide Web and is the gateway to your entire enterprise. It's the gateway, it's the bridge. It's like the bridge collapse, and it's the only bridge that leads to a city or a town. So the impact will be felt, right? Super felt. That's what we're trying to say here. So if a router fails, the impact is felt. So it depends on which device fails in your network. That will determine the kind of impact that you're going to have. If a switch fails, the LAN suffers, the entire LAN, the building, the whole building where you have all your workstations. We're going to suffer. It's going to suffer if a switch fails. If a router fails, bigger than the building. So if a router fails, like maybe the entire campus will not have a internet. The entire campus will not have internet. If a router fails, maybe it's only the building, the faculty of business administration that will have problem. A faculty of engineering will have network. Faculty of ICT, we have network. Faculty of Human Science, we have network. Faculty of Medicine, we have network. Okay, that's if a switch fails. So if an APA access point fails, it's not the whole building. It's not the whole faculty that will have problem. Maybe just the room, 1 room, 2 rooms, and so on and so forth that will have problem. So it depends on what fails, which device fails in a network that determines the impact that will be felt in the enterprise network. Is that okay? Okay, so I hope this is clear. We'll move on. The functions of the device that fail, we already explained this. Now we say use a redundant link and reliable enterprise class equipment to minimize the disruption in the network. So you see why we create a redundant link. One reason why we create a redundant link. So when there is a failure, then we switch to the redundant link as quickly as possible in order to minimize the financial loss of the organization. Smaller failure domains reduce the impact of the failure, but also make the troubleshooting easier. Not only easy impact, but troubleshooting is also easier. Is that okay? Now let's quickly go to increasing bandwidth. How do we increase bandwidth? In a hierarchical network design, some links between access and distribution layer switches may need to process a greater amount of traffic than other links, right? So to do that, we use what we call the Ethernet channel. Ether channel, okay, what we call the Ether channel. The Ether channel is a kind of arrangement where a router bringing data from a gateway. A router is the gateway itself, bringing data from the internet, converges to a switch, and another router bringing data from Ethernet converges to the same switch. So 2 routers converging at the same switch. That configuration arrangement is called Ether channel. Now this Ether channel has a lot of advantages. One of the biggest advantages it has is that it helps to increase the bandwidth of the network, or the bandwidth of the LAN, local area network. Is that okay? So that's this thing. As multiple links converge into a single link, it is possible for this link to become a bottleneck. It's possible if you bring in so many things to one single link, multiple links are converging at one link, there's definitely going to be traffic, there's definitely going to be a lot of bottleneck, a lot of problems. You might even have system failure. So one way that is used to minimize these problems or these bottlenecks that may arise from this when multiple links are being linked to one channel is to use what we call the Ether channel. Ether channel is a form of link aggregation. It's a form of link aggregation that will allow the network administrator to increase the amount of bandwidth between the devices, and by creating one logical link out of several physical links. So you have so many physical links that will be linked together using what we call the Ether channel, and this will enhance the bandwidth and give a better system performance. So Ether channel uses existing switch ports, okay, uses existing one. You don't have to create new ports. Ether channel configuration takes advantage of load balancing between links that are part of the same Ether channel. Now let's move on quickly. Expanding the access layer. Expanding the access layer. How do we expand the access layer? If we want to expand the access layer, we just need to use what we call the wireless local area network. Yeah, because if you are using only wired network, there is to a certain limit that we can go, because the number of ports that are available, because of the number of ports that are available on the switch. So there is a limit that we can go in our network, okay, of workstation we can create within our network. So if we dare to expand it, then we need what we call the wireless local area network. So to do that, first we talk about the wireless connectivity. And we know that this wireless connectivity has become, in today's world, has become an integral and very important aspect of extending the access layer connectivity in our network, right? Now, the network must be designed to be able to expand network access to individuals and devices as needed as possible, right? Today we have mobile phones, and every individual has one or two or three mobile phones, and each of these mobile device has its own access link. So we need to create something that will enable, if you have 10,000 students on a campus, each person has an access link, and you need to be able to have something that can take care of that. Something that can take care of that. Okay? So let's take a look at the advantages of wireless connectivity. Let's take a look at the advantages of wireless connectivity. It includes increased flexibility, reduced cost, ability to adapt to changing network and business requirements. Okay, so these are the advantages of wireless. Increased flexibility, is very flexible. You can just take your phone, move about, take your laptop, move about in a network area. You don't have to be fixed to a point or a port. You can move around. So that's one advantage. Another advantage is reduced cost. It's cheaper than wired network. Another advantage, ability to adapt to changing network and business requirements. Okay, so these are some of the advantages. Now, let's take a look at the edge devices require a wireless. Every edge devices, like your mobile phone, your laptop, they need what we call the network interface card. Every end device has to have what we call the network interface card that incorporates the radio transmitter. It will incorporate the radio transmitter and receiver. And not only the radio transmitter and receiver, it will also incorporate the software drivers that will enable connectivity. Okay? And also a wireless access point. Also, every mobile phone or laptop has what we call the wireless access point that enable connectivity. Is that okay? Now let's move on quickly. Fine-tuning routing protocols. Okay, here in a network, you design your network area, useful network areas, maybe area 1, area 5.1, and so on and so forth. Like, remember we said you have to develop a backbone. You have to create a backbone, a redundant area called the backbone area, which has to be connected to the very existing one that are very useful to you. Now, the protocols we use, according to Cisco, there are two very pragmatic protocols. The leak state protocol, which use the OSPF protocol, called the OSPF protocol, and the distant vector routing protocol, which is called the EIGRP. The EIGRP stands for Enhanced Interior Gateway Routing Protocol. Enhanced Interior Gateway Routing Protocol is a distant vector routing protocol, whereas the OSPF, which is the Open Shortest Path First, is a link state protocol. Now, these two protocols are used in our routing on our network. But the Cisco proprietary routing protocol is the Enhanced Interior Gateway Routing Protocol. This one was developed by Cisco, okay, to route data packets within routers, switches, and our workstations. Is that okay? So this one was developed. It's a distant vector protocol developed by Cisco for routing the data packets, okay, from the various areas on the network. Now, like we said, the OSPF support a layer 2 hierarchical design, which is called the multi-area. The multi-area is the backbone area that supports a redundant area that supports maybe when there is traffic, provides itself, made itself available. And remember we said when you have a backbone area, you must develop the STP, the spanning tree protocol, routing protocol. You have to develop it in order to avoid looping of the network. And then since we call the backbone area, the multi-area OSP requires a backbone, what we call the area 0, to be developed in designing a network. You have to design the backbone area, and then the non-backbone area must be connected directly to the backbone area in a network. Now, advanced routing protocols such as the OSP, OSPF, and EIGRP are used in large networks. So every large network, like the campus network or big enterprise network, we use these two routing protocol, the OSPF. OSPF stands for Open Shortest Path First routing protocol. Like I said, this OSPF is a link state protocol, a link state from one network to another network. This routing protocol is very suitable. It's a link state protocol. The second one, which was developed by Cisco, is the EIGRP routing protocol. It stands for Enhanced Ethereal Gateway Routing Protocol, and is a Cisco proprietary routing protocol, and is a distance vector routing protocol. It's a very nice routing protocol for all Cisco devices on our network. Is that okay? So we move on quickly. Cisco proprietary routing distance vector routing protocol, called the EIGRP, is another popular routing protocol that is used on the network and is designed for larger network using the primary Cisco routers. Okay, so when you're using Cisco devices like the Cisco switches, Cisco routers, then it is very appropriate to use the Cisco software, the routing protocol, the Cisco routing protocol, which is called the EIGRP protocols. Is that okay? So although the configuring the EIGRP is very simple, configuring any Cisco protocol is very simple because they've put it in a very simple manner. Now the underlying features and options of EIGRP are extensive and very robust that supports our network. Now we go to the second part of this lecture, which is called selecting the network device. Here we'll be very fast. We'll just, because we've taught switches, routers, and access point in previous courses, right? You've done this in previous courses. So we're going to run through what we believe we've known. So we're not going to waste time as in case of the first section of this lecture. Now let's quickly take a look at, as final year students, you should be very conversant with all these things. We've done them in your first year, second year, third year. So we should be very conversant with some of this. Now let's take a look at what we have. We have modular configuration switches. We have different switches, Cisco switches, as Zebo showed on the pictures, right? On the picture as above. Now let's take a look at what are these things. We said there are 5 categories of switches, right, in our enterprise network. We have the campus LAN switches, we have the cloud managed switches, we have data center switches, which are used in data centers. We have the service provider switches, which are used by the service provider, internet service providers, like the TM, Telecom Malaysia. Then we have the virtual networking switches, the one for wireless, and so on and so forth. Then we have the various factors. Here, we look at the various factors to consider when you're selecting the switch, the type of switch you are going to use. You have to look whether is it a fixed switch that you need for a fixed location, or is it going to be a modular configuration that you need? Do you need a fixed configuration or a modular configuration? So that is one of the factors to consider to know which type of switch to buy for a network. Another factor to consider to know which type of switch to buy for a network is stackable. Is it stackable or is it not going to be stackable? Stackable means like on a shelf, or it's not going to be a stackable one, or it's not going to be on a shelf. Okay, so it's a factor to consider to know which type of switch to buy. And then another factor to consider is the thickness of the switch. Okay, the rack unit, the thickness, how many racks or ports you can find on the switch. So is it for a large network, small network, medium network? So that data. Then another thing is the cost. And is a small network, you don't have to go and buy very expensive switches or with so many ports. The port density, we have to consider the port density, the power, the reliability, and so on and so forth. Is that okay? Now let's quickly take a look at the port density. Port density is the number of ports available for use per switch, right? Now if you take a look at this one has 24 ports switch. This is a 24 port switch, and this is 48 port switch. And this one is a modular catalytic 6500 modular switch. Now, what is port density? Port density of a switch refers to the number of ports on a single switch. How many ports are in a switch? That's what we mean by port density. If you have 24 ports in one switch, that's the port density is 24. If you have 48 ports in a single switch, the port density is 48. But we have a very big modular case where you have ports of over 1000 on a single port. Okay, so port density refers to the number of ports on a single port. Now let's move on quickly. Forwarding rates. Let's take a switch hardware. One of the job the switch do is to forward data packet. When they receive from a router, they forward to the destination. They forward data packet either to routing table or to the destination. So the forwarding rate is something to look at. Switch product lines are classified by their forwarding rate. So how much they can forward. Forwarding rate defines the processing capability of a switch by rating how much data the switch can process per second. You know, they faster than each other. How much data the switch can process per second and forward these data packets to their various destinations. Is that okay? Entry-level switches have lower forwarding rate, of course. These are for small networks. Okay, they are for small network and they are used for small level enterprise. Okay, forwarding rates is a very important factor to be considered when you're selecting a switch, because you cannot need, if your enterprise is very big, or as a network engineer, the enterprise you're developing for is very big, you cannot go and select a switch with a very small forwarding rate. Okay, it will not be a good network design and it will not work well with that network. Is that okay? Access layer switches typically do not need to operate at full wire speed between the devices. Okay, so let's move on quickly. Now let's go to what we call the power over Ethernet. We call it PoE. Power over Ethernet allows the switch to deliver power to device over the existing Ethernet cable. So what it does is allows switch to deliver power to existing Ethernet cable. Okay, so as you see here, you can see the switch will deliver power to this device through this cable, deliver power to this place through this cable. Okay, so power, we've studied this in lower grade. This eliminates the need for power cables. You don't need to bring a power cable. So the switch will deliver power to the devices themselves. Is that okay? And this device include the IP phones and the wireless access point. The IP phones and the wireless access point in your network. So power over Ethernet allows more flexibility in installing wireless access points and IP phones by allowing them to be installed anywhere, okay, that there is no Ethernet cable. There is no Ethernet cable, you can still install IP for as long as they are connected to the switch itself. So when they are connected to the switch will deliver power to them. It's called power over Ethernet, okay, using the Ethernet cable. Is that okay? Now let's move on quickly for the sake of time. Now, multi-layer switching. Multi-layer switches are typically deployed in core and distribution layer level, okay? Multi-layer switches can do this task, can build a routing table and support routing protocols, can forward IP packets at a rate close to that of layer 2. You know, layer 2s are routers. So they can do, this multi-layer can do the task similar to that of router. They can forward packets at a very fast rate. Okay, multi-layer switches often support specialized hardware called the application specific integrated circuit, ASIC. Application specific integrated circuits is a very important thing, right? These ASICs, along with the dedicated software, can streamline the forwarding of IP packets independent of the CPU of the computer. Without the CPU, without the brain of the computer, it can do the job of whatever the CPU is supposed to have done. Okay? Okay, so let's move on. So let's take a look at router requirements. What are the requirements for a router? When do you decide to bring a router to a network? Okay, why do we need a router? What job do router do for the network? Okay, now routing is required within the distribution layer. Remember that. The routing is required the routers are needed for distribution layers of any enterprise network. Without routing, packets could not leave the local area network. If you don't have router, you cannot send from this office to another office. You can only work within the same office. You can only work within the same office and send data packet within the local area network. If you want to forward data packet from your office here in Kuala Lumpur to office in Lagos, Nigeria, you need to have what we call a router. Without a router, you cannot send to one wide area network. So you only operate within a local area network. You cannot send any data packets to a wide area network over the internet. You cannot. Okay, so routers are very important in network configuration and design. Okay, routers are critical networking device. Why? Because of the following tasks they do. What they do for you. One, they help you to connect your businesses and your homes to the internet. Your home router will help you to connect it to the internet. So if you don't have a router, so even within your house, your wireless network you have within your house, okay, when you have a Wi-Fi, that small box you see is a router. It's going to connect your home to the internet. Without a router, you cannot connect to the internet, the wide area network. Without a router, you cannot interconnect multiple sites within an enterprise network. So within your campus network, you cannot connect the multiple sites like different faculties together. You cannot. Without a router, you cannot connect the internet service provider on the internet. Even the internet service provider's office cannot be connected to the internet without a router. Without a router, you cannot translate between different media types and protocols on the network. Without a router, you can see how important a router is. In fact, is the heartbeat of a network, okay? A wide area network. If you want to extend to the internet, in fact, you cannot have a gateway to the internet without a router. Is that okay? So finding alternate path is also a function. Alternate path, if a leak or path goes down, is a very fine function of a router. Now, but this is not only limited. The functionality of router is not only limited to the functions I've just described. Okay? It's not only limited to the functions that we have just described. Now, let's take a look at some of the critical functions that are also important that I have not mentioned. One of it is the broadcast. The routers provides the broadcast containment by limiting the broadcast to the local network. It will contain the broadcast. Okay, it's called the broadcast containment to only the local area network that is this data packet is designated to. It contains it to that network only. That's one big and huge functionality that we've not described or discussed. Another big functions of the router is that routers are able to group users logically by application or by department. What do you mean by group users? Routers is so brilliant or designed to be brilliant to be able to identify the faculties of engineering. This data packet is going to faculty of engineering. This data packet is going to faculty of business and administration. This data packet is going to this department. Not only faculties. It can even segment it to different departments. Department of electrical, department of civil engineering, department of network engineering, department of cyber security, department of accounting, department of fintech, department of whatever, AI and this thing. So it's able to distribute them according to department. The router is as brilliant as that, able to segment data packets logically by application. Another functions of the router, beautiful function of the router that cannot be overemphasized, is that router provide enhanced security through the use of access control list. You know, we've talked about access control when we are doing network and cyber security last semester. Okay, we talked about the access control list when we studied the network and cyber security. Okay, so router is able to provide this access control list. So if a hacker is trying to access your network, the router is able to access to see whether these data packets are in the list, the access control list, or then it will filter it, any unwanted traffic, and block any unwanted traffic. So security is a function of a router. Router is able to provide security to your network. Okay, that's what we mean by that. Router also provide what we call interconnect geographically separate location. Router will connect your office in Lagos, Nigeria, to your office in New York, United States, to your office in Kuala Lumpur, Malaysia, to your office in Osaka, Japan. Router is the gateway that connects all your geographically separated locations. Is that okay? So Cisco router are of different types. So since we've known the function, now let's take a look at the different categories of router. Cisco routers are of different types. We have the branch router, the network edge router, and the service provider router. Number one, the branch router. The branch routers optimize branch services on a single platform while delivering an optimal application experience to any branch or across branches within the one infrastructure. Okay? A good example is this picture. This one is called the branch router. This is how they look. The routers we use in various branches of our network. This is how they look. Now the second one is the network edge routers. Network edge routers enable the network edge to deliver high performance, highly secured and reliable services that unite campuses, data centers, and branch network. So it unites the data centers and your branch network and your data and your campus. Okay, a good example is what is shown in this picture. Take a look at this picture. You see a good example how the network edge router looks like. The third one is the service provider router. As the name implies, this is the type of router that are being used in the internet service used by the internet service providers, like the TM. Okay, so the service provider routers are obviously typically going to be different from the routers we use in our offices, right? In our enterprise network. So you say these routers differentiate the service portfolio, okay, because they are providing services to various offices, various network, various infrastructure. So it should be able to be, the router will be huge, and they should be able to differentiate the service portfolio and increase the revenues by delivering the end-to-end service or scalable solutions and subscriber-aware services to the users. Now let's take a look at the router hardware. Routers come in many forms, right? They come in many forms. They range in different sizes. You have the 800 series, which is for small office. You have 2900 series for large branch offices. You have the 2000 series for industrial routers designed to operate in harsh and rugged environment in the industry. You have the ASR 1000 series aggregation router service. They provide aggregation services for what we call the channel throughput that we've described earlier on. And then we have the Cisco CROS, Cisco Carrier Routing System for data centers and service provider. This one, this huge one, they're used by data service provider. Okay. Now let's take a look at the managing devices. How do you manage? We have what we call the inbound versus outbound management. Outbound, let's start with the outbound. Outbound is the configuration you do when there is no network. You know, when you just buy a router, there's no network, right? The configuration that you do to your router and your workstation, your computers, is called the outbound service. Now, here you are configuring the outbound, you are configuring the cursor port, you are configuring the auxiliary port. This is what all this configuration that you do regarding your cursor, your auxiliary, they are called the outbound router configuration. Inbound router configuration includes when we now have that you have the network, the Ethernet interface. You are now connecting the interface and the IP interfaces. When you are configuring those Ethernet interface, IP interfaces, then this is called the inbound router configuration. Okay, but before we go to the configuration mechanism, remember the inbound management is used to configure and monitor the device remotely through network connection using the HTTPS and the SSH, right? Now, for security reasons, the use of Telnet and HTTP are not recommended. Don't use HTTP for interconnectivity. Use HTTPS. Is that okay? Telnets are not. It doesn't provide secured network. Now let's quickly take a look at managing our devices. Let's take a look at the basic router command line interface. Some of the commands that you need to configure as a network administrator. Now, when you buy a router, you want to design the network. These are some of the, when you have to configure the router, configure the switches. We run through this because we've done discuss before something about configuration in the router. So let's quickly take a look at router. You say router to put it in the mode. You have to say router hashtag configure terminal. Okay, and then you enter. This will take you to the configuration command. Okay, and you do one per line, and you end with the CNTL/Z. That's how you. So once you configure router hashtag configure terminal, it will take you to the command line interface where you start doing your configuration. Excuse me. Now, this configuration starts by saying router config hashtag. You put the host name router 1. Okay, maybe the host name is router 1. You call it router 1. Then, after you've configured the host name, then you start using the host name, right? You not say router config again. You just say router 1 because you configure the host name. The host name is router 1. So you say arrow 1. Arrow 1 means router 1, right? Router 1 config hashtag enable secret class. Secret is the password, right? The password you've enabled now is class. You can call your password anything you want to call it. Router 1 config, that's the password of the router, okay? You have to write down all this so you don't forget. Router 1 config hashtag line cursor 0. You have to configure the cursor line. Router 1 config, since you configure the line, now we include the line. Router 1 config line password Cisco. Okay? Router 1 config line hashtag login. Configure login, meaning they have to log in. Router 1 config line hashtag exit timeout. So you go to configure timeout. Router 1 config line hashtag line virtual terminal 1 to 15. Router 1 config line hashtag password is Cisco. Router 1 config line hashtag login. Router 1 config hashtag exit. You know, you go to configure all of this, the clock rate, router 1 config hashtag, router 1 config, after you configure the interface, router 1 config hashtag interface gigabit ethernet 0/0. So you must configure the interface gigabit ethernet 0/0 before you can begin to configure the clock rate, the LAN, the IP address, the no shutdown, meaning it should continue running, interface serial interface 0/0. All of this you configure. The clock rate 128,000. Okay, all of this you configure, and so on and so forth. So all this configuration you have to run on your router. Is that okay? Okay, so these are the things: the host name, identification, password for security, IP address, and so on and so forth. Basic routing protocol. You have to configure the routing protocol. The ROIP is a routing protocol. So router 1 config hashtag router ROIP, meaning you've configured the routing protocol, the IP address, and so on and so forth. So if you want to verify or save configuration changes, you put router 1 config copy running config startup config. So you type this command, and then you'll be able to, if you want to stop or clear your configuration, you say router 1 config erase startup configuration or reload. Everything will disappear that you've done. Okay, so that's that. And the other command like show IP address, it will display your IP address. Router 1 config hashtag show IP address, IP protocol, to show all your IP, show IP route, to display all the routes that are available that you have configured. Router 1 show interface, to display all the interface. Okay, so that's that for that. Now we go to still on the router, more show IP interfaces, show IP interface brief. IP interface brief will show you the important IP designations that have the show IP protocol, show CDP neighbors. If you want to see the neighbors, the routers that this particular router is configured with, Okay, show IP neighbors, it will display the IP neighbors. Now this is for switch, similar, just that way we are using router, we use switch, similar characterization. So to configure, you use the same command line interface, switch command line interface. You say switch hashtag enable to put it in the configuration mode. Then you say switch hashtag configure terminal. After that, it will take you to the configuration mode proper. Then switch config hashtag host name switch 1. The host name is switch 1. So we start using switch 1 config hashtag banner, switch 1 config enable password Cisco switch 1 config. You do the same similar thing on the switch mode. The IP address, the interface, the Ethernet, and so on and so forth, the login and everything that we've described in the previous page, okay, for switches. So if you want to display command, you want to show after you finish configuration, you want to see what you've done, you begin to show switch 1 config hashtag show port security to display all the security. Show port security address to display that. Show interfaces, it will display that. Show MAC address table, it will display the MAC address table. Show CDP neighbors, it will show you the switches upon which this particular switch is configured to, and so on and so forth. So here is the summary. Summary is I have questions for you to try, okay, as an assignment, and to be submitted next week. You say, explain why it is important to design a scalable hierarchical network. And the second one is select a network device based on the features, capability, and network requirement. Okay, so to be submitted next week. So with this, we come to the end of our today's class. Thank you for joining us.